Hello, boys and girls. Here we are going to study about the rotational dynamics. And now, in rotational dynamics, we are studying about the applications of uniform circular motion. Last time we had considered about the second application, and that second application was a vehicle which is moving along the bank curve road, and for the bank curve road the vehicle has a certain speed limit, and that speed lit we had derived. And that speed limit we had derived last time, and the equation was Vs. Equation was Vs is equal to under root Rg tan theta. So this was the equation for the bank curve road speed limit, and this speed limit is called as most speed limit. This speed limit is called as most speed limit. Means whenever a vehicle is moving along the bank curve road with this speed of most safe speed, then we can imagine that the frictional force is negligible there. Frictional force is negligible there, means very close to zero. Means without considering the frictional force, we can consider the vehicle which can move safely along the banked road with this speed, that means the most safe speed. Okay, but practically most of the times vehicle will not move exactly with this speed Vs, that means the most safe speed. The vehicles may move with the lower speeds or higher speeds than the most safe speeds. Okay, so now we can continue the same topic, that means the bank road. We can continue the same topic, and then we will consider for the given bank road, there may be the lower limit of the vehicle's movement and upper limit of the vehicle's movement. So we can solve for two speeds or velocities, that means the lower speed limit generally indicated by V1 of the vehicle and the upper speed limit indicated by V2. Means for the given bank road, vehicle can move with the lower speeds or higher speeds than the most safe speeds. So we have to consider, or we have to study about the lower speed limit and the upper speed limit. Let us see the situation 1, that is the figure 1. Figure 1 describes the lower speed limit of the vehicle, and figure 2, second figure, describes the ideas about the upper speed limit of the vehicle. So let us see one by one. So this is the bank road. This is the actual surface of the road, and this is the horizontal direction. This road surface makes some angle theta with the horizontal. Okay, and this vehicle is moving towards left, performing circular motion along this bank road, and while moving the circular motion or while performing the circular motion, the related informations are means radius of the circular motion, and theta means banking angle for the given bank road. So this is the figure in which the vehicle is moving, and this This dot point is called as the center of gravity point of the vehicle, and now this vehicle is acted upon by the number of forces. Number of forces. Last time, while deriving the relation Vs is equal to Rc tan theta, we had considered the two main forces were acting on the vehicle. And two main forces were, first force was the mg acting downward. Second force is the normal reaction force. Normal reaction force N, which is perpendicular to the surface, road surface. So these two forces mg and N, these are the two forces we had considered while deriving the Vs. Now to consider or to study the lower speed limit, that means the V1, now we have to consider the role of the frictional force. When the vehicles are moving along the bank road with the lower speeds or higher speeds. So let us see, the vehicle is moving with the lower speeds. That means the lower speed limit V1. Vehicle is moving with the lower speed, that means the less than Vs. So when the vehicle is moving with this lower speed, then the third force will come into action. That force is nothing but the frictional force Fs. This force we will get when the vehicle moves with the lower speed, then we get the frictional force in such a way that the direction of the frictional force always lies along the direction of the surface. This is the direction of surface, and it always present along the direction of the surface, but directed upwards. So this is the actual direction of the frictional force Fs. Frictional force Fs directed along the surface and directed upwards, and it is always equal to mu s n. Frictional force always equal to mu s n. It depends on the normal action force. So let's see. The first force mg, second force n, and then this n, normal reaction force, forms angle theta with the vertical direction, which is similar to this angle theta. Okay. Now the components of the normal action along the vertical upward direction, that will be n cos theta. Along the horizontal direction, it will become n sin theta. So this is the first component of the normal reaction force acting vertically upward direction. This is the second component of the normal reaction force acting horizontal direction. And directed towards the center of motion or center of circular motion. So these are the two components of the normal action force. Now let's see the third force. Third force is the frictional force. Frictional force which opposes this frictional force which opposes the tendency to slip down the road. Tendency of the vehicle to slip down the road. That is why the direction of the frictional force lies always upward directed to oppose the slipping down. So this is the third force Vs directed along this direction. It makes an angle theta with the horizontal makes angle theta. Now find the components. Find the components of the frictional force. Two components. First along the horizontal direction, second along the vertical upward directions. So this is the horizontal direction. This direction is the adjacent side of this actual force direction. So adjacent side component will be Fs multiplied by cos theta. Fs multiplied by cos theta. Adjacent side component always obtain whenever we multiply by the cos of theta. Whenever we multiply by the cos of theta to the given vector, we get the adjacent side component. And the next component which is perpendicular to the first, this is the next component which is perpendicular to the first. The second component, this is the first component Fs cos theta. Then second component which is perpendicular always equal to Fs sin theta. Fs sin theta. So these are the two components. These are the two components which is of the frictional force. So this is the diagram. In this diagram, we are going to consider the speed limit, which is the lower speed limit v1. Means this is the v1, value v1, which is the smaller velocity or lower velocity than the vs. Vs is equal to rg tan theta. So now we can consider for speeds v1. For speeds v1 means lower speeds v1. V1 is smaller. V1 is smaller than the rg tan of theta. V1 is smaller than under root of rg tan of theta. That means the Vs. That is the Vs. So V1 is smaller than Vs. Whenever the vehicle has a lower speeds, means the speeds are actually lesser than the most safe speed. Then the related centripetal force, required centripetal force of the vehicle will be smaller than the n sin theta. Will be smaller than n sin theta. What is n sin theta? N sin theta, this is the component. N sin theta, this is the component of normal action directed towards the center. Directed towards the center means this component acts as or behaves as centripetal force. Centripetal force. But whenever the vehicle is moving with lower speeds, at that time, this component n sin theta always greater. N sin theta always greater than the mv1 square r. That is the required centripetal force or actual centripetal force of the vehicle. So mv1 square divided by r less than n sin theta. Less than n sin theta. So this is the situation according to which when the vehicle is moving with lower speed, then we can write v1 is smaller than under root of tan theta. Its other meaning is that centripetal force, related centripetal force. v1 is the lower speed, then the related centripetal force will be mv1 square upon r, and it will be smaller than the n sin theta, which is actually present in this situation. So mv1 square upon r less than n sin theta. Okay. Now in this case, here Fs is the frictional force and is directed upwards along the surface. Now in this figure, along the upward direction, this is the first component and this is the second component. These are the two components which are directed upward directions, and to this direction there is opposite direction, that is the vertically downward direction. There is vertically downward direction, only one force is there, that is the weight force. Means weight force mg is balanced by these two components. That means the Fs sin theta plus n sin theta is always equal to mg. So we can write here from figure mg is equal to n cos theta or Fs sin theta plus Fs sin theta. So along the vertical direction, mg is balanced by n cos theta and Fs sin theta. Along the horizontal direction, the n sin theta is directed towards the center, but fs cos theta, that is the component of fs cos theta, directed outward direction, radially outward direction. So these two components are oppositely directed, and they adjusted in such a way that and gives rise a resultant single force, and that resultant single force is nothing but the centripetal force. Okay, so n sin theta and fs cos theta are oppositely directed, but they doesn't cancel each other, but they minimize the effect. And produces a single resultant force, which is nothing but the resultant centripetal force. So these two forces gives rise centripetal force, necessary centripetal force. And we know this is the necessary centripetal force, and V1 square divided by R, and this centripetal force in this circular motion, this is the required centripetal force, and this is the required centripetal force is nothing but the difference between these two components, difference between these two forces. That means the n sin theta minus fs cos theta. So these are the two equations. 1 and 2 we can construct or we can write from the given figure. Means whenever the vehicle is moving with the lower speeds, that means with these conditions, when the vehicle is moving with these conditions, then we can write these two relations. Now, equation 2 by equation 1. Equation 2 divided by equation 1. Equation 2 divided by equation 1 is 2 by 1. We get mass we get cancel. V1 square divided by Rg. So equation 2 divided by equation 1, we get V1 square upon Rc at the right hand side. Equation 2, n sin theta minus fs cos theta divided by equation 1, n cos theta plus fs sin theta. So equation 2 divided by equation 1, we get V1 square upon Rg is equal to n sin theta minus fs cos theta divided by n cos theta plus fs sin theta. Continue at the right hand side, but we know fs means mu s n, frictional force or force due to the static friction, that is called as the frictional force Fs, and this frictional force always depends on the normal action, but equality we can write Fs is equal to mu s n. Place this equation in the previous equation and then we can solve. Therefore, considering the equation Fs is equal to mu s n and then divided by n cos theta at right hand side. This is the right hand side. There are two terms at the numerator, two terms at the denominator. To every terms means 1, 2, 3, 4. To each terms which are present at the right hand side, we have to divide by n cos theta. divided by n cos theta and use the value for the fs is equal to mu s n. Then we get v1 square divided by rg. v1 square on rg is equal to n sin theta divided by n cos theta. n sin theta divided by n cos theta. n get cancelled, but sin upon cos we get tan theta. We get tan theta. Then minus sign. fs means mu s n. fs means mu s n. fs means mu s n multiplied by cos theta. fs means mu s n multiplied by cos theta. Then divided by the n cos theta. Divided by the n cos theta, we get n cos theta cancelled. Remaining factor is only mu s. So whenever we divide this factor by the n cos theta, we get mu s. That means the mu s. Then divided by now at the denominator there is n cos theta. n cos theta divided by n cos theta means n cos theta divided by n cos theta means 1 plus fs sin theta. fs means mu s n. fs means mu s n. fs means mu s n multiplied by sin theta. So multiplied by sin theta. Then divided by n cos theta. Then divided by the n cos theta. And n will get cancelled. Mu s multiplied by sin upon cos means tan. Means mu s tan theta. Mu s tan theta. Okay. Then rearranging the equation, v1 square divided by rg. Transfer rg towards the right hand side. rg in the bracket tan theta minus mu s 1 plus mu s tan theta. So v1 square is equal to, shift this rg at the right hand side, we get rg, then multiplied by the bracket. Okay. Then last step is square root. Take the square root on both sides. Square root of the both sides. We get left hand side v1 and v1 is at the right hand side root. v1 is equal to under root of rg multiplied by tan theta minus mu s divided by 1 plus mu s tan of theta. This is the relation 3. And this equation number 3 gives the lower limit. From this equation we can decide the lower limits of the vehicle which is moving along the bank or road. Okay. Then the upper speed limit for the vehicle which is moving along this bank road we will see in the next video. Thank you.